Okay, solving inequalities. So remember, when you're solving inequalities, that's where we're going to want you to create a number line, find x values, and then you're going to find these intervals that make it the area true or false. You'll plug it back into the inequality to figure that out. So here's an example. So what's the opposite of positive 4? Negative 4. The opposite of positive 7 is negative 7. This one you have to be careful, because if you say, well, the opposite of negative 4 is 4, well, negative 4 plus negative 4 is negative 8. So what we actually have here is another negative 4, because the opposite of negative 4 is positive 4. 4 subtract 4. So look at, we have a duplicate. We have two negative 4s. We have x is equal to negative 4, a multiplicity of 2. And remember what I said, what happens there, they'll end up being a parabola if we were to sketch that. But so we just have these, even though it is a cubic, x times x times x, we actually just have two roots because one is a duplicate. And then what you do is you pick values in the intervals, not the values themselves, values in the intervals. And I say keep it easy on yourself. So if you put negative 10 in here, the opposite of negative 10 is positive 10. 10 subtract 4 is positive. So we have a positive times negative 10 plus 4 is negative, times a negative, times negative 10 plus 7 will be a negative 3, times a negative. Well, a negative times a negative is a positive times a positive is a positive. Is a positive number less than 0? False. And then we're going to plug negative 5 in. So the opposite of negative 5 is positive 5. 5 subtract 4, that's going to be a positive. Negative 4, negative 5 plus 4 is negative 1, so that will be a negative. And then negative 5 plus 7, that will be a positive. And then a positive times a negative is a negative. A negative times a positive is a negative. Is a negative number less than 0? That area is true. And then I'm going to plug in 0. Well, 0 subtract 4 is a negative, times, then we have a positive times a positive, whoops, because 0 plus 4 is positive, 0 plus 7 is positive. So a negative times a positive is a negative. Then a negative times a positive again is a negative. Is a negative less than 0? This area is true. So be careful. Sometimes you can have two segments right in a row that's true. And look at, this is why remember, this was a multiplicity of 2. There's going to be, if we were to graph this, this is probably, it would look something like this. Notice, we're going to have a negative times a positive. We're going to have a negative cubic and a bunch of other stuff. We're going to have a negative cubic, so it's going to start this way and go that way. Then remember, we had a multiplicity of 2, so there's a parabola right there. So both of these areas, these intervals, this interval and this interval, make that statement true. All right, let's see. Then, when you have a quadratic, you're going to have to factor it. Well, the first thing, we have a negative number here, so I'm going to factor out a negative 1. And when I do that, this becomes positive, this one becomes negative, this returns to positive, and then I'm going to factor that quadratic, and it factors to 3x subtract 1, 2x subtract 1. So the you do the opposite of -1, which is +1, and the opposite of multiplying 3 is dividing 3, so x is equal to 1/3, and this one, x is equal to 1/2. So 1/3 is going to go here, 1/2 is going to go here, and then you're going to pick, and this is going to be trickier, you're going to pick, there's 3 intervals right there, and to keep it easy on yourself, whoops, there we go. I would go ahead and pick 0 here. I would pick 10 here. This is going to be tricky. What you could do is convert 1/2. 1/2 is 0.5, 0.333 repeating, or 0.3 repeating. Well, halfway between 0.333 or partway, you could put 0.4, which is 4/10, or another way to say that is 2/5. So however you do that, that would be the value that you pick. So in your calculator, you could pick 0.4. That would make it easy. You plug all of that into here would be fine, and you find which one makes it true or false, and I'm going to let you do that on your own. And right here, notice they give us, you just have to say x is equal to -4. The opposite of 4 is -4. The opposite of -6. But look at, there's going to be 2 of those, a multiplicity of 2. That means right here, there's going to be, whoops, x is equal to 6. That looked like -6. There's going to be a parabola, so it's probably going to do something like this. It'll probably look less curvy than that, but I didn't have enough room. So you're going to find your values. And look at, if you graph this area, let's see, is greater than 0. This area should be false. This area should be true. And this area should be true. But we should probably check it. So I'm going to pick -10. I'm going to pick 0. And I'm going to pick +10. So here's a negative number times, well, a negative squared will be a positive. A negative times a positive is negative. Is a negative greater than 0? False. We're going to put 0 in here. That's a positive. Well, that'll be a negative, but a negative squared is a positive. Is a positive greater than 0? True. And we're going to put 10 in here. Positive times a positive, true. All right, and I think, and this one, you're going to do some synthetic division. I would first factor out a -1, then you're going to do synthetic division. And when I tried 1, it worked. X is equal to 1. Remember the rational root theorem, those possibilities are going to be positive and negative, 1 and 2, factors of the constant, over factors of the lead coefficient, so 1, 3, and 9. And so that's how I picked my values. I tried 1/3. 1/3 worked, so x is equal to 1/3. And then I tried 2/3, and 2/3 works. So then you can do your number line. So we had 1/3, or 0.333, and it continues. Or I could just write 0.3. 2/3 worked, so 0.6 repeating, and 1 worked. So in this one right here, I might choose this interval, 0.5. This, let me change that color. 0.5, I would probably choose 0. 0.6 repeating, I might choose 0.8. And I might choose 10. And you just plug that in to the original and see which area makes it true. And I'll let you guys all do that on your own. All right, that's it for this one.